In lesson 1, we looked at how you can determine the limiting reagent of a given chemical reaction. In today's lesson, which is lesson 2, we want to look at a more detailed example as we explore further how you can determine the limiting reagent of a particular chemical reaction. We are going to look at example 2 to deepen our understanding. Let's read example 2. 25 grams of magnesium metal is mixed with 500 cubic centimeters of phosphoric acid of concentration 1.5 moles per cubic deciliter. The reaction occurs at standard temperature and pressure. Determine the limiting reagent. That's the first part of that question there. The first thing that we must do is to write down a balanced equation for the reaction between magnesium and phosphoric acid. Generally, on most questions that you do, you are generally given a balanced equation, but I've already done that for you, so that takes care of that part. We can see from the balanced equation that 3 moles of magnesium reacts with 2 moles of phosphoric acid to form 1 mole of magnesium phosphate and 3 moles of hydrogen. Now, if you look at the question, we have been given quantities of our reactants, but not in moles. So the first thing is to convert the amount of magnesium and the amount of phosphoric acid to moles using any of the 3 formulae that you learned when you, 3 of the formulae that you looked at last year when you looked at quantitative chemistry. You can use this formula, you can use that formula, or any relevant formula to convert whatever amount that we have to moles. If you convert 25 grams of magnesium to moles using this formula, you end up with 1,042 moles of magnesium to start with. And if you convert phosphoric acid that we have to moles, you end up with 0.75 moles of phosphoric acid. So to start with, we have 1,042 moles of magnesium and 0.75 moles of phosphoric acid. The next thing that you need to do now is to see how much of the product you are going to form from each of the reagents that you have. I'm going to choose hydrogen. If I was to use all the magnesium, how much hydrogen would I form? Or if I was to use all the phosphoric acid, how much hydrogen would I form? I'm going to refer to the balance equation. Obviously, you know that for every 3 moles of magnesium, you form 3 moles of hydrogen, and for every 2 moles of phosphoric acid, you form 3 moles of hydrogen. Now, using this stoichiometric coefficient, I determine how much hydrogen I can form if all of the magnesium was to be used in the formation of hydrogen gas in the previous reaction. So, for every 3 grams of magnesium, for every 3 moles of magnesium, you form 3 moles of hydrogen. So if I put 1,042 moles of magnesium, you are going to form X, whereby X stands for the number of moles of hydrogen that is formed. And if you solve that using direct proportion, you end up with 1,042 moles of hydrogen. In the same way, from our balance equation, you saw that for every 2 moles of phosphoric acid, you can form 3 moles of hydrogen. If I've got 0.75 moles of phosphoric acid, I can form Y moles of hydrogen. If you solve that using direct proportion, you form 1,125 moles of hydrogen. Now, if you compare the amount of hydrogen which is formed from magnesium and the amount of hydrogen which is formed from phosphoric acid, what you will notice is that the amount of hydrogen which is formed from magnesium is less than the amount of hydrogen which is formed from phosphoric acid. What that means is that magnesium becomes the limiting reagent. Because once magnesium is used up, we can no longer form any more hydrogen. Therefore, the limiting reagent in this context is magnesium. So that is our full answer to 2.1. So the limiting reagent is magnesium. So the substance that forms the least amount of product is the limiting reagent. Once it gets used up, you can no longer form any more product. Let's look at 2.2. On our example, what is the maximum amount of hydrogen gas which we can refer to as the theoretical yield that can be formed in cubic decimeters? Right, we are going to use our answer from 2.1. The amount of a product is determined by the limiting reagent, and our limiting reagent is magnesium. Now we know that for every 3 moles of magnesium, we form 3 moles of hydrogen gas. But the amount of limiting reagent we have is 1,042, and as a result, the amount of product in terms of moles that we can form from the limiting reagent is 1,042 moles. So this becomes the theoretical yield, or the maximum amount of hydrogen that we can form from the limiting reagent. But if we look at our question, the answer must be given in cubic decimeters. So you must convert the theoretical yield given in moles to the theoretical yield in cubic decimeters using this formula, converting number of moles, the theoretical yield in moles, to the theoretical yield in terms of volume. So we are going to convert 1,042 moles of hydrogen, which is our theoretical yield given in moles, to volume using this formula. If you make V the subject of the formula, your volume is equal to number of moles times molar volume. So the maximum yield of hydrogen, which is called the theoretical yield, is equal to the number of moles, which is 1,042 times 22,4, and the final answer is 23,34 cubic decimeters, which is the theoretical yield as given in cubic decimeters. I hope this example is going to enhance your understanding in determining the limiting reagent and theoretical yield in the subsequent exercise that you are going to do at the end of this lesson.